Hello, Algebra students, and welcome to another lesson in Algebra 1. We are moving into Chapter 6, and we are talking all about something called systems of equations. So in our last chapter, we talked about lines. The whole thing was about straight lines in the coordinate plane. Now we're going to have two lines put together in the same problem. It's going to be turned into something called a system. What I'd like for you to be able to do by the end of this lesson is to be able to define what a system of equations is and to solve them by graphing. So hopefully it'll be a little bit of review for you. So first of all, what is a system of equations? A system of equations is a set of two or more linear equations. So basically you have two lines in the same problem. Any ordered pair, x, y, that makes both of the equations true, it's important that both of them are true, is the solution. So in example 1, it says, what is the solution to the system? Use a graph. All we're going to do is use our equations and graph them on our coordinate plane first. So these are in slope-intercept form. Let me remind you what that is. That is y equals mx plus b. When something is in y equals mx plus b form, the m is the slope and the b is the y-intercept. So to graph both of these, I am going to start with the y-intercept and then use the slope from there. So let's identify what those pieces are in each equation. In this first one, b is equal to 2, and m, or the slope, is invisible. It's that invisible 1 in front of the x, so the slope is 1. So let's graph this first one. If b is 2, I'm going to go on my y-axis up to 2 and mark that. So 1, 2, put a mark. Then I use my slope from there. So remember, slope is equal to rise over run. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to keep doing that in both directions so that I can see where my line is going to be. And there's my first line. Now I'm going to graph my second equation on the same graph using the same strategy. So what is the b? The b is negative 2, and m is equal to 3. If you need to put it as 3 over 1 so you can see that, that's okay. So first, graph your y-intercept, and I'll use a different color just so you can see that it's a different equation. So we're going to go down to negative 2 right here. And then it has a slope of 3, which is rise over run, so that means up 3 over 1. So up 3 over 1, up 3 over 1, up 3 over 1. So there is my second line. The solution to the problem is where the lines intersect, at that point right there. So that means my final answer is going to be this coordinate, or 2, 1, 2, 3, 4, 2, 4. So the coordinate 2, 4 is my answer. I'm going to make a little note for you just because it is important. So note where the lines intersect is the answer. That's pretty important because that's where we're going to be finding our solution for all of our problems today. So where the lines intersect is the answer. Okay, let's do that again in two more examples just so we can get a little bit of practice. So my first equation is y is equal to 2x plus 4. I'm going to label the b as 4 and m is 2 because remember this is in the form y equals mx plus b. Okay, So first let's graph the b at 4. So that's going to be right here. This is my y-axis, and because it's saying my y-intercept is 4, I go up 4 on my y-axis and make a point. Then I have a slope of 2. So that means I need to go up 2 over 1, up 2 over 1. When I run out of space, I can do the same thing in reverse. So that means I can go down 2, back 1, down 2, back 1. Okay, I'm going to connect my dots now just so I have my graph. So that's my first equation. Let's graph the next one. The next equation has a y-intercept of 2 and a slope of 1. So I'm going to graph my y-intercept of 2 first. So I'm going to go up 2. And then it has a slope of 1. So that's up 1 over 1, up 1 over 1. But I can also do the same thing in reverse. So down 1, back 1, down 1, back 1. When I connect all my dots, I get my second graph, or my second graphed line. Now remember what we set up here. Where the lines intersect is the answer. So I'm going to look at the coordinate where the lines cross each other, which is right here. The coordinate is going to be my solution. So that is at the coordinate -2, 0. Doing it one more time right here. For my first equation, I have a b of -2, and I have a slope of -3. So I'm first going to graph the -2 on the y-axis. So 1, 2. And then I have a slope of -3. Remember, when a slope is negative, it needs to be going downhill from left to right. So that's an easy way for you to correct any mistakes. So if you counted, this would be the wrong way to count it. If you counted up 3 and over 1, notice how this line would be going uphill. We don't want it to go uphill because it's a negative slope. So I can easily tell if an answer is right or wrong just by looking at the direction that the line is graphed. Instead, I need to go down 3 over 1 or up 3 backwards 1. Connect the dots, and that's my first line. To graph my second line, notice I have my y-intercept at 3, and my slope is 2. So first I'm going to go to the y-axis, and I'm going to graph the 3 there because that's what my y-intercept is. So I'm going to go 1, 2, 3. Now from this point on, I'm going to use my slope of 2. A slope of 2 means up 2 and then over 1. So up 2 over 1, up 2 over 1. When you run out of space, you can do the opposite of what you just did. So instead of up, you go down. Instead of to the right, you go to the left. So I'm going to go down 2, backwards 1, down 2, backwards 1. Connect your dots. One more time, your answer is where your lines intersect. So that is at the coordinate -1, 1. And there's your answer. Now we have two other special types of solutions that I want to talk about with you now. They're systems with infinitely many or no solution. We do have situations like that as well. And I'm going to show you the different types so you can see what I mean. So first, let's look at this equation or this problem. I have the equation 2y minus x is equal to 2, and y is equal to 1/2 x plus 1. This first equation is not in slope-intercept form for me. I need it to be in the form y equals mx plus b. So I need to solve for y in order to get it into the right order for me. So I've got 2y minus x is equal to 2. I'm going to start solving by isolating the y. So first I'm going to add x to both sides. That gets me 2y is equal to x plus 2. I want to get rid of this 2 in front of the y because I'm trying to make this equation down here match my formula up here. So I'm going to divide by 2, and that gets me y is equal to 1/2 x plus 1. Okay, now I have my equation. I'm able to graph it. So I'm going to first start with my y-intercept at 1, and then it has a slope of 1/2. So that means rise 1, run 2. So up 1 over 2, up 1 over 2, up 1 over 2. Down 1, back 2, down 1, back 2. So now I'm connecting the dots. Looking at my second equation though, notice how my second equation is exactly like this one. This one says y equals 1/2 x plus 1, and this one says y equals 1/2 x plus 1. So I'm going to graph it in the same exact spot. I start with the 1, and then I have a slope of 1/2, or up 1 over 2. So my other equation, or my other line, literally falls directly on top of it. When I have two lines that are perfectly on top of each other, when they are the same equation, we have to ask ourselves, well, where are these lines touching? Where they intersect is the answer. There's intersecting everywhere. So that means infinitely many solutions. Or all real numbers. I can say that as well. Let's look at this example right here. My first equation is 2x plus 2. So I'm going to go to the 2. That's my b. And then I have a slope of 2, which is rise over run. So that's up 2 over 1. So up 2 over 1, up 2 over 1. I'm going to connect my dots. Let's do my second equation. This is y equals 2x minus 1. The minus 1 is the b, and the 2 is the m. So first, I need to graph my y-intercept at -1. Then I need to graph the slope of 2. So that's up 2 over 1, up 2 over 1. I'm going to connect all my dots. Notice how these two lines are going in exactly the same direction, but they are not on top of each other. These lines are parallel. Now, remember this key statement that we had on the previous. Note, where the lines intersect is the answer. Well, parallel lines never intersect. They are beside each other, but never crossing. Because there is no point of intersection, this one has no solution. We're going to do one more example of each of those just so you can see it one more time. So in this example, I have y is equal to -x minus 3 and y is equal to -x plus 5. Let's graph the first one. So my b is -3. My y-intercept is -3. So I need to go down 3 on my y-axis and make a point. Now this says -x. Remember, when you do not see a number, it's an invisible 1. So this is actually a slope of -1. So that means I need to go down 1 over 1, down 1 over 1. Because it's a negative slope, it's going downhill. Connect your dots. And there's your first line. Now we're going to graph the second line. This one is -x plus 5. This time the y-intercept is +5. The b is 5. Because remember, these are in the form y equals mx plus b. So I'm going to go up to the 5 and put a dot on it. This one also has a slope of -1 because there is an invisible 1 right here. So I'm going to go down 1 over 1, down 1 over 1 to graph my lines. When I do that, notice how these lines are going in the same exact direction. They have equal slopes. So we know equal slopes means they're parallel. Therefore, there is no solution to this problem. The reason there is no solution is because they do not intersect. And when lines do not intersect, they do not have a solution to the system. Our last example. This one says y is equal to 3x minus 3. Graph your y-intercept first, so that's down 3. Then I have a slope of positive 3. That means up 3 over 1, up 3 over 1. We're connecting our dots again, if I don't miss them. There we go. This guy is 3y is equal to 9x minus 9. It is not in slope-intercept form yet, or slope-intercept form, I apologize. I need it to look like the equation y equals mx plus b. This 3 in front of the y is in the way. I don't want the 3 to be there. So I'm going to divide by 3 on both sides, and that gets me y is equal to, now I'm going to divide both of these terms by this lower 3. So 9x divided by 3 is 3x, minus 9 divided by 3, which is 3. Notice this equation and this equation are exactly the same now. Y is equal to 3x minus 3, y is equal to 3x minus 3. So when I graph this, it's going to be right on top of the other one. And when two equations are directly on top of each other, that means they're intersecting across their whole space. So this is all real numbers or infinite solutions. And there you have it. That's how you solve systems of equations by graphing. Have a good night.